there! Did you want to create some cool physics art without having to do any of the design yourself? I thought so. We've got the square plate on the mechanical vibrator, which is plugged into the tone generator. This vibrates the plate at different notes as we change the frequency here. I'll sprinkle a little sand on the plate, and now watch this. Why does this happen? As I tune the plate to vibrate at very specific frequencies, or notes, the sand moves on the plate into beautiful, though unusual, patterns. As I find higher and higher special frequencies, the patterns on the plate get more intricate. How awesome is this? But it does kind of sound like a dying ferret. Why does it happen? The main concept here is resonant modes. Let's back up a little bit to the physics of waves. In physics, a wave is a disturbance traveling through a medium or through space. If I constrain my medium at the other end, the wave reflects back at me. See? Now, if I send continuous waves down the slinky, they also reflect back, and what I get is two waves, one moving away from me and one moving at me. But obviously the rope can't be in both places at once, so as my incoming wave reflects back, I don't see both waves, I see a combination of the two. The waves add when they're on top of each other and subtract when they're opposing one another. And something crazy is happening. You've got a wave going this way combined with a wave moving that way, and when they interfere, the result is, as you might expect, a wave that doesn't appear to be moving in any direction. It's standing! This is called a standing wave. And so is this. The places where the wave appears to be not moving at all are called nodes, and the places where they're moving a lot are called antinodes. Now that we've mastered standing waves, let's go back to our square plate. If you look closely, there are places where the plate and the sand are moving a lot, and places here where they're not moving at all. These are nodes, just like the nodes that didn't move on our slinky. Here are the antinodes. And just like we needed specific frequencies to get standing waves on our slinky, the same is true of our plate. These specific frequencies are called resonant modes, and they're caused by waves traveling out from the center, bouncing off the sides, and interfering with each other just right so we get standing patterns. Also, the higher the frequency, the closer together the nodes, just like the slinky. But now, what if you did this in 3 dimensions? You could have vibrations coming from the sides and from the front and back, and you'd get interference from all of these such that there'd be nodes in mid-air, places where the air is completely unmoving, and you could, hypothetically, place an object there and cause it to levitate. That would be crazy. But it's exactly what researchers from the University of Tokyo and the Nagoya Institute of Technology did. Well, that's all I got. Really, the physics is the cool part. So, stay tuned to see the vibrations on these plates.